Today's that will be introduction to microwind, layout design of a CMOS inverter. We have to know how to design the layout design, the layout, that is the mask layout. This is a manual design. Remember, this is manually designed. There are many ways. There are many ways by which you can design. You can design the layout. There are many ways. One rule I will teach you. You can also learn the stick diagram flow. This is stick diagram method. You can also learn the stick diagram method. What is stick diagram method? Okay, let me show you what is the stick diagram method. Stick diagram of CMOS. Okay, this is called stick diagram. Stick diagram means this diagram is the stick diagram. Then this diagram is the mask layout. Okay, mask layout. So this is actually the similar thing. That means how you are going to draw the stick diagram. Actually, you will convert the stick diagram into what? Into mask layout. Okay, this is actually easier. This is easier, but I would like to teach you the manual method. So I will teach you the manual method. You can learn this by yourself. This is pretty simple, pretty easy. খুবই সহজ, খুবই easy. তুমি নিজে নিজে শিখতে পারবে. You can learn by yourself. Okay. And this is a not get. Remember, this is a not get. How do I know it is a not get? How do I know? Because you have one MOSFET here and one NMOS here. As you can see, this yellow color is the P diffusion. That means the P type, right? And the green color is the N diffusion, that means N type. And the red color is the gate, because it is polysilicon. Silicon dioxide, polysilicon is the gate. That's why it is connected to these NMOS and it is connected to the PMOS. The upper one is the VDD, the lower one is the ground, because there is a blue color. Blue color is the metal one. Okay, metal. And their drain is connected to the metal, and it is to your output. Okay, metal port. And this is your input, and this is your ground. This is your what? This is your VCC. And the dot, that means the circle, is the contact. Here is the contact. Here is the contact. Here is the contact. Square is the combined contact and tap. Combined contact means normally the connection will be from VCC and the ground, as you can see. They are from the VCC and the ground, right? And the square but hollow, that is called tap. Tap means from here you will take a connection to somewhere else. Okay, it is very rare, but you can see that. You can see that as well. This is called tap. Understood, everyone?
Yes, sir, understand.
Okay. This is the stick diagram method. Stick diagram. So this is the stick diagram method. Now it is also easier. Remember, this is also easier. My method is also easier, but my method is a bit elaborated. Here, this is a manual design method. I will teach you how to draw these. Okay, how to draw these in the DSCH. So I have free software. As you can see, I have given you the software. So this DSCH we have already done. Untitled Chapter we have already done. This is the microwind. That is the software we want to do today. So I'm going to extract this in the desktop. What happened? Yeah, it is finished. Okay. So no, it is not finished. extract it. Okay, here you have one folder called system. This is the folder you want to open. There you have 5 files. One is microWin31. Okay, this is the application you want to open. Now this is very familiar to you, right? This is exactly like your DSCH. Can you see that?
Yes, sir.
But it is a bit different. At first, you can see there's one thing called 5 lambda. Depending on your monitor resolution, these will be 5 lambda, 1 lambda, 10 lambda, depending on your resolution. Okay, so your job will be, at first your job will be selecting the foundry. Go to the file. When you open the software, go to the file. At first, click select foundry. Okay, first work is select foundry. From there is a rule folder. What folder is this? This folder is actually this one, the rule folder. Can you see the rule folder? So if you get some other folder, you go to that folder and select CMOS 90 nano. CMOS 90 nano, because my calculations are all for 90 nano. If your company or if your design has different nanometer process, you can use different nanometer process. But my calculations are all for what? All for 90 nano. Okay, so I select 90 nano. So after that, you have to make this 5 lambda to 1 lambda. 5 lambda to 1 lambda. Okay, everyone. So how to do that? This is how you should do it. You should click these 2 buttons, plus and minus. If you click plus and minus, they will zoom in or zoom out. Okay, so sometimes they will not work like this. Sometimes you have to click here and click here, click here and click here, click here and click here. Okay, got my point? So this is how you should get 1 lambda. Can you see the 1 lambda? When you get 1 lambda is the one you should get. 1 lambda means this is 1 lambda. 1 lambda means 1 slot. What? 1 slot. Okay, this is 1 lambda means 1 slot, 2 slot, 3 slot. So all the measurement will be in lambda. So 1 lambda, 2 lambda, 3 lambda, something like that. So now I want to make this NMOS. So how to make this NMOS? Very simple. There are 2 ways I say. One way is this one, stick method, right? Another method is the conventional method that I have shown here. So here, remember, one is for PMOS, another one is NMOS. So NMOS, so I will start with N diffusion. Here you can see there are many things. One is N diffusion, P diffusion, N well. I'm starting with N diffusion. If I take the N diffusion, here the length will be 14. And the width will be 6. There is a reason for that. Okay, the length, here the length is 14. Here the width is 6. There is 14 lambda and 6 lambda actually. So how do we know it is 6? See, 1, 2, 3, 4, 5, 6. Okay, 6 lambda, that is 6 slot. If you divide 1, 2, 3, 4, 5, 6. So 6 lambda. And here you will have 14 lambda, that is 14 slot. There is a reason for that. This is the minimum value. There is you can make it bigger. You can take 7, you can take 10, you can take 20, no problem. But you cannot go beyond that. You cannot go smaller than that. Why? Because in 90 nano, you have to give contact. There's some contact, right? Like this. Contact for metal, you have to have some contact. Those contact need what? Those contact need some spaces. So this is N type. So I will go and use a N type contact. That is this one. Can you see the N? Remember, what type of contact is this? If I go there, if I click here, what type of contact is this? N plus diffusion slash metal 1 slash metal 1, right? Contact N plus diffusion slash metal 1. So it is metal 1 contact. So click there and bring it and place it here. Obviously, there will be some gap, one gap, one gap. Okay. Now this is for source or drain, whatever you want to use it for, your wish. It is either drain or source. So you have to design. You have to take one for your source as well. If it is drain, that will be source. Take another N and place it here. Okay. So in the middle, the gap should be 4. That's why it is 14, because this one is 4. So extra 1 5, then extra 1 6. Here you have 4 10. So in the middle you have 4. So 14. Got my point? Why it is 14? The middle gap should be 4. Here the gap should be 1, at least 1, at least 1. So that's why total gap should be 14. And here it is 4. The upper one, the gap should be 1. The lower one, gap should be 1. That's why minimum of 6. This is your N-type material. For a P-type material, you have to do the exact same thing. But this time, you have to use the P plus diffusion, P plus. And I will make it at the top because P must always remain at the top. And I will give a gap. I will give a gap of 12. 12. How do I know it is 12? See. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 gap, right? Remember, 12 gap. So when it is 12 gap, so you have to draw a P diffusion. Now remember, the length will be same. Why? Because in our coding 1, remember W was 12, L was 3, right? For NPMOS. For NMOS, W was 4, L was 3, right? Remember?
Yes, sir. Yes,
so
sir.
it was for 3:1. It was for 3:1. If it was 2:1, then what would happen?
Yes,
if
sir.
it was 2:1, then it would be 8, not 12. Got my point? So let's consider it is 2:1, not 3:1. So if, remember, in all cases, length will be same. All length will be same. Only difference is width. If width is 4 here, it will be 8. If it is 6 here, it will be how much? So what is the width?
6, sir.
6. So how much width it will have?
12.
12. So we have to make it 12. So how to make it 12? We made some mistake here. Mistake is we didn't take 12. So how to make it 12? How to modify it? See here, you have two what is that? Two buttons. One is move, another one is and one is copy, another one is move. Move or stress. Stress means you can modify any edge. So here, if I click here, and if I click this line, now I can increase it. Okay. So it is 8, 9, 10, 11, 12. So this is 12. Understood?
Yes, sir.
Okay, now I need P diffusion, P type. This time I will not take N type, I will take P type. P এর জন্য P নিতে হবে কিন্তু. I will take P and place it at the middle. I will take P, I will place it at the middle. So one is drain, another one is source. Okay. Next, I have to use N well. Why N well? This is P type. The whole material is P type material. The whole black portion, this whole black portion is P type. In P type, you are taking P type. It is not possible. So in P type, you have to make an area that is N type. Got my point? In N type, you have to make PMOS. Got it, everyone? So you have to take one N well. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to change this one. 1, 2, 3, 4, 5, 6. So this should be 6, 6, 6, 6 extra. 6, 6, 6, 6 extra. Okay. This is called N well. That means you are actually making some area for your PMOS. Okay. For PMOS, you are making an area with N types. So this is the N well. So you have to give the N well. So your structure is ready. Now you have to make the connections. First connections, gate connection, gate. So how to make the gate connection? Using polysilicon. This is polysilicon, not 2. Remember, there are 2 polysilicon. One is polysilicon, 2. Another one is polysilicon. So only polysilicon. So we'll take the polysilicon. This is how you should make the connection. Remember, the polysilicon should be 2 lambda at least. At least 2, not more than not less than 2. It should be 2 or it can be 3 as well, but it should be at least 2. Since we have taken the length is equal to 14, so there is no way you can make it 3. So it should be 2 now. Okay, it should be 2. So because there you have to give some space here, you have to give some space here, and it is connected. So it should be 2. And one more important thing, you have to give some extra. Extra is 3. You have to give some extra. 3. If you see the website I have shown you, you can see there is some extra, right? Can you see that?
Yes, sir.
Some extra?
Yes, sir.
There is some extra. So this extra should be there. So how much extra? Upper one 3, lower 3. Okay, 3, at least 3. You can give more than 3, no problem. But at least 3 should be there. Is there any error? Let's check any error. There is a button called DRC. DRC is the design rule checker. If I click this, if any error happen, it will show me. Okay, let me make one error. I have given 2 only, not 3. The upper one is 3, lower one is 2. If I click this, there will be an error. See, right? But they are saying the extra poly surrounding diffusion is less than 3 lambda. So it should be at least what? At least 3. Now if I click all, the all thing will come here. And if I click DRC, no error. Now the connections. Connections means
VDD and ground, sir.
so where will be the VDD? At the source, right? This is source, this is drain, this is drain, this is source, right? At the source of PMOS will be VDD. Which one is source? Let's say this is our source. This is drain, this is drain, this is source, right? Got it? So here, let's take some connections. Let's take some connections. Metal 1, using metal 1. Remember, metal 1. Metal 1. I will give some VDD here. What is the VDD? Here is the VDD. So if we double click, it should be 5 volt, not 1.2 volt, 5 volt. Okay. The ground, the lower source will be the ground, right? So let's take a metal connection and go down and give the ground here. Understood, everyone?
Yes.
Hello? Have you understood?
Yes, sir.
Yes, sir.
Okay. Now,
Yes,
the,
sir.
now the drain should be connected. Drain. So these drain and these drain should be connected. So how to make them connected? Remember this metal, the width of the metal should be at least 3, at least. I have given here 4, right? I have given 4, right? 4 is okay, but it should be at least 3. Remember, it should be at least 3. Okay, everyone? Now, one more important issue, where you will put your input, where you will put your output. Where you will put your input. Anyone? Where you are putting your input?
The inputs from sir.
Polysilicon, right?
The silicon, yes, sir.
Yeah, here you will give your input. Where you will put your output?
From drain.
Drain, that is here,
Yes.
right? Okay. So for input, I am going to use a pulse. The fourth one, pulse. Can you see that? Add a clock.
Yes, sir.
There, you will say add a clock. Click there and bring and place it here. Please give the name as A. The input voltage should be 5 volt. The lower should be 0 volt, and the time should be like that. Okay, do not touch the time. If you want to touch the time, you can. And I normally do not touch the time. Then output. Input is given. Now the output. Output will be the last one. The visible node. That means the oscilloscope. Visible node. Click here and bring it here. Rename it to Y. And it should be clicked. Visible in simulation. If I have one more issue. In the N well, I have to give one VDD as well, extra VDD. Here, 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 anywhere. Double click, it should be 5 volt as well. This is one extra step you have to do. Now, our design rules called no error. Okay, there is no error. Let's check the simulation. Can you see the simulation?
Yes, sir.
Okay, here when it is 1, your output is 0. When your input is 0, output is 1. At the first step, you will have some error, and there will be some glitches. This is because of the mechanical manual design. For manual design, there will be some glitches. Okay, there will be some glitches. So I'm going to stop my class here. After 20 minutes, I will start the class again. Okay.
Okay, sir.
Okay. So I will give you a separate link. In this 20 minutes, you practice. Okay, everyone?
Okay, sir.
Oh. So we will be back at 12:10. We'll be back at 12:10. Is that okay?
Okay, sir.
Okay.